Assalamu alaikum.
Hi, I'm doing module industrial chemistry and I'm doing focus point 4, which is the industrial production of sodium hydroxide requires the use of electrolysis. First up is explain the difference between galvanic cells and electrolytic cells in terms of energy requirements. And so there's just a table of comparison. So electrical energy is produced by chemical reactions in galvanic cells, whereas in electrolytic cells, it's the opposite. So electrical energy is used to produce a chemical reaction. Galvanic cells produce electrical current. Electrolytic requires an input of electrical current. Galvanic is spontaneous. The anode is negative and the cathode is positive. While in electrolytic cells, the reaction is forced. The anode is positive and the cathode is negative. Next dot point is outline the steps in the industrial production of sodium hydroxide from sodium chloride solution and describe the reaction in terms of net ionic and full formula equations. So industrially produced sodium hydroxide is made by electrolyzing a concentrated sodium chloride solution, which is formed from purified seawaters or from underground salt mines, and it should be fairly concentrated to form chlorine gas as a byproduct. Sodium chloride is electrolyzed with hydrogen gas forming at the cathode, while chlorine gas forms at the anode, and these following is just the equations for it. Next is distinguish between the three electrolysis methods used to extract sodium hydroxide, so the mercury, diaphragm, and membrane processes, by describing each process and analyzing the technical and environmental difficulties involved in each process. So this is just a diagram of the mercury cell. The anode is the titanium rods. The cathode is liquid mercury, which flows along, and the electrolyte is the saturated brine, which is put in through there. Okay, so the process is mercury flows across the sloping floor of a large tank, and the anode plates are suspended very close to the mercury. The brine then flows slowly through the first tank, resulting in the chloride ions oxidizing on the titanium anodes and the sodium ions reducing on the mercury cathode. The chlorine gas is then bubbled out and collected, and the sodium dissolves into the mercury, forming an amalgam or blend. The amalgam then flows into the second tank containing purified water, and the sodium spontaneously reacts with the water to form very pure sodium hydroxide and hydrogen gas. The hydrogen is then bubbled out and collected, and the sodium hydroxide is tapped off. Some technical difficulties include pure fresh brine is required, and this is really expensive, and the depleted brine must be continuously replaced with fresher brine, which again expensive. Lots of heat is produced in the decomposer chamber, therefore it needs to be cooled. The high voltage required for this process is energy intensive, which is again expensive, and sodium hydroxide is corrosive. Environmental issues are some mercury may escape into nearby waterways. This is a concern as it is a heavy metal and also a neurotoxin, so it can result in severe health issues for the people that are exposed to it. And also chlorine gas is a strong oxidizing agent. Next is the diaphragm cell. So it consists of two compartments that are separated by a porous diaphragm. The anode is carbon, the cathode is steel mesh. Okay, this process involves when the electrolyte solution soaks through the asbestos diaphragm to the steel mesh, the electrolysis reaction occurs. So the asbestos diaphragm prevents the products from mixing, and it allows the water and NaCl solution to flow between the electrodes, but it separates the chlorine and hydrogen gas, preventing the OH ions from flowing towards the anode. Chloride ions from the brine migrate towards the anode and are oxidized, for it, and then sodium ions migrate towards the cathode, but are too stable to reduce, therefore water is reduced instead. And then there's the overall reaction. So technical difficulties are chlorine and hydrogen must be separated as they react vigorously to form the corrosive HCl gas. A large number of cells are placed together in order to maximize the current, and unwanted ion movement may occur across the asbestos diaphragm, so small amounts of chlorine may cross it and react with the sodium to form NaCl in the final product, which acts as an impurity, and hypochlorite, which is a strong oxidizing agent, may also be present. Environmental issues are the asbestos fibers. They're quite dangerous respiratory irritants, and the inhalation of these fibers can cause a range of lung diseases, and the depleted brine cannot immediately be released into the environment due to the presence of small quantities of basic sodium hydroxide and hypochlorite ions, which have to be removed first. finally is the membrane cell. So this is a single cell divided into two halves by an ion exchange polymer membrane. The process is purified, concentrated sodium chloride solution is acidified with hydrochloric acid and then passed into the anode half cell where chlorine is produced. Then water flows through the cathode half cell where it is reduced to form hydrogen and hydroxide ions. And the selectively permeable membrane allows the diffusion of sodium and water only. Chloride and hydroxide ions cannot pass. The sodium ions then pass through the membrane and combine with the hydroxide ions, forming very pure sodium hydroxide, which is continuously removed. Technical difficulties are, this isn't really a difficulty, but this cell solves the problem of both of the previous cells. So no toxic materials are used, such as asbestos, mercury. Also, very pure sodium hydroxide is formed as the product isn't contaminated with chlorine ions. The polymer membrane also has many useful properties, such as its selective permeability and its ability to resist chemical attack in a strongly basic solution. Environmental difficulties are, so because of the nature of the membrane and the inert electrodes used, there are only a little bit of environmental difficulties. One such is leakage of chlorine gas and sodium hydroxide into the environment, and the excess brine must not be deposited into the waterways as it will increase salinity and upset the natural balance. Okay, these are just some non-specific technicalities. So the location of a plant where this process is have to take place is a technical consideration that must be in accordance with the availability of the following. So cheap electricity, as this is the most major cost, access to cheap brine as well as fresh water sources, local workforce willing to work at suitable expenditure, and it has to be built away from urban and residential areas due to the large amounts of noise and heat that the plants emit. Okay, this is a practical dot point. Identify the products of the electrolysis of sodium hydroxide. So this is just a comparison table. So with saturated sodium chloride, the anode, you will see a slight green tinge, and a wet paper test will indicate the presence of chlorine when it becomes bleached. Okay, and then at the cathode, it will collect a greater value of gas than the anode, so you'll see a lot more bubbles, and colorless gas. If this gas is lit, and you can test it with the pop test. Then with the dilute sodium chloride, the gas made a glowing slit burn brightly, which proves that oxygen is present. And at the cathode, gas burn is allowed up, so again, pop test and prove the presence of hydrogen gas. This is the second practical dot point. Predict and explain the different products of the electrolysis of aqueous and molten sodium chloride. So electrolysis of molten, concentrated and dilute solutions of sodium chloride yield different products. The products of electrolysis can be predicted using two concepts. The more concentrated an ion, the more likely it will be oxidized or reduced, and certain species are always oxidized or reduced more readily than others. By looking at the table of standard reduction potentials, reactions can be predicted. Okay, so electrolysis of molten sodium chloride. The only ions present in a sample of this are sodium and chlorine, and so they are the only ions that will be oxidized and reduced, and the following are just the equations for that. Then for the electrolysis of aqueous sodium chloride, in concentrated, the solution will also contain water molecules, and in this chloride ions are just as likely to be oxidized compared to water molecules. However, due to the high concentration of chlorine ions in a concentrated solution, chloride ions are preferentially oxidized at the anode, and then water is more readily reduced than the sodium ion, hence sodium simply migrates to the cathode while water is reduced. In a diluted sample, water is reduced over sodium ions. However, it is also oxidized over chloride ions because of the low concentration of chloride. And this is the equations for it. This is a HSC question from the 2003 HSC paper. Outline the procedures you use to identify the products of electrolysis of sodium chloride. This is a very common question in the HSC. I've seen it at least 5-6 times when I was going through the papers. The main things for the 3 marks, you have to identify the products, identify the test used to get each product, and the results if the product is present, so a positive test result. And so this is just an example. Chlorine gas, you will see a yellow color and a distinctive swimming pool smell will be smelt. And you can test this using moist litmus paper placed near the electrode. It will be bleached white. And for sodium hydroxide solution, it's produced at the cathode, so you just add phenolphthalein, and a pink colour around the cathode indicates the presence of the hydroxide ion. And for hydrogen gas, clear bubbles are formed at the cathode. A positive pop test indicates the presence of hydrogen gas. Okay, this is another question from the 2003 paper. This is from the 2007 paper. So over the past century, the production of sodium hydroxide has evolved from the mercury process to the diaphragm process to the membrane process. Analyze the factors that contributed to each of the changes in the production process. This is 6 marks. So to get all 6 marks, you need to give a brief description of the electrolysis of concentrated sodium chloride solution and support it with equations. That's 2 marks. And then for the 4 marks, you need at least 4 factors that contributed to these changes, such as the contamination of the product by sodium chloride, recognition that asbestos is an environmental hazard, lack of recognition for many decades that small discharges of mercury metal into the oceans were dangerous, and the development of a membrane cell that overcame all of the disadvantages of the previous 2 cells. Okay, this is the last question from the 2010 HSC paper. Compare the electrolysis of molten sodium chloride and aqueous sodium chloride. Write the relevant half equations and overall reaction for each process. So this is 5 marks. It's a compare question, so you need similarities and differences along with the required equations. So some similarities and differences are both require an external source of energy to drive the reaction. Molten, however, requires more. Different states are required, so molten you need pure NaCl in liquid form, aqueous you need it in aqueous form. Both chloride ions are oxidized in both cells, however in molten sodium chloride, sodium is reduced, in aqueous, water is reduced. And then molten sodium chloride, it produces only sodium and chlorine, so those are the reactions. And aqueous sodium chloride products depend on the concentration of the sodium chloride solution, so depending on if it's diluted or